Unit 1 Study Guide, page 1. So the first skill that we're going to need to be successful is going to be rewriting radicals and rational exponents. So this first one here, we're given the fourth root of x to the 7th power. So we want to rewrite that as a fractional exponent, so something that looks like that. So remember that 4 here is your root, and the 7 here is your power. Remember, when your power goes on top and your root goes on bottom, so when we go to rewrite this, our base is x. So we know our power is going to be a fractional exponent, so our power is going to be in the numerator, and our root is going to be on the bottom. And that's your final answer. Going on the second one, it's in a fractional exponent already. You can see that fraction right there, and it's in the exponent. So we want to rewrite this as a radical. Our base is x. Our root is 9. So that 9 is going to go right here with the square root. And the 2 is our power. It's going to be our exponent. And we write that there. And that is our final answer. So you need to be sure that for this test you know how to go from one to the other. Okay, going on to number 2. Applying the rules of exponents to simplify the expressions, all exponents must be positive. So it's a good thing to write these down on your note cards, at least the rules. So we have 7x to the negative 4 times negative 2x to the negative 3rd power. So first thing we're going to do is going to multiply the coefficients. 7 times negative 2 gives us negative 14. And then remember, when you're multiplying like bases, right, we have x times x here, x to the negative 4th power times x to the negative 3. When you're multiplying like bases, you add the exponents. So negative 4 plus negative 3, however you want to write it. Right, so we simplify that down, we get negative 14 times x to the negative 7th power. Now, notice here it says all exponents must be positive, so we can't have any negative exponents, and our exponent currently is negative. So that negative 7, it only applies to that x there. Right, so remember, you have to make this into a fraction, and that negative exponent means that term is not happy being upstairs, and you got to drop it downstairs in the denominator. So your final answer, then negative 14 stays up top, and x, and this time, since we're moving it, it's happy with where it's at and it becomes positive. It's going to be x to the 7th. Okay, so remember that rule. When you're multiplying like bases, you have to add the exponents. Okay, now that second one, I'm going to go ahead and erase this so I have some room to work with. The second one here, we have an exponent raised to an exponent, right? So we don't see 2 parentheses like we did on the last one. We just see 1 parenthesis, and we see 1 exponent, and it's raised to another exponent. So this is another rule that would be good to write on your note card. When you have an exponent raised to an exponent, you multiply your exponents. So we're going to take 2/3. We need our base. X to the 2/3 times negative 3 over 5. Remember, when you're multiplying fractions, you just multiply straight across. This is going to simplify down. So 2 times the negative is negative 2. And 1 times 5 is just 5. So now simplifying this out, I'm going to go ahead and write this. Let's see, I'm going to start it back up here where this arrow is. So we have x to the negative 2/5. Oop, that's not a 5, that's a 2. X to the negative 2/5. Now, same rules apply. We don't want any negative exponents, so we have to put this over 1. This whole thing, right, that negative 2/5 applies to the x, so that's going to get dropped to the denominator. So now that we removed everything from the top, we have to replace it with a 1. So I'm going to go ahead and write the answer over here. 1 over and we drop it to the denominator where it's going to now be happy and positive, x over 2 fifths. And that's your final answer for that middle one. Okay, I'm going to go ahead and erase this again so I have more room. If I'm moving too fast for the video, you guys are always welcome to go ahead and pause it and go back and rewatch it. Okay, next one. We have 3x to the 5th power divided by 6x to the negative 2. Okay, so notice that this time that our bases are being divided. So the rule is when you're dividing like bases, you have to subtract your exponents. So first thing I'm going to do, I'm going to go ahead and simplify this 3/6 here. I know 3/6 is equal to 1/2. We can reduce this fraction. So I'm going to reduce it to 1/2. And then my base is x. And I know I'm going to be subtracting my exponents, right? Because I know I have like bases and they're being divided. So it's 5 minus negative 2. Okay, now that's going to turn this into a positive because I have a double negative here. So it's 5 plus 2, which is 7. So now I have 1/2 x to the 7th power. Since it's positive, I'm going to throw it in the numerator. X to the 7th over 2 is my final answer. Okay, now I'm going to go ahead and go on to number 3. So it says solving equations with rational exponents, radicals. Be able to discern when it is appropriate to use a calculator and when not to. So looking at the first one here, we have x to the 4/5 power equals 16. Now our first step should always be to get x by itself. So what I'm going to do to get x by itself is I'm going to raise this side to the reciprocal exponent, 5 over 4, which means I have to raise the left side 5 over 4. Now remember, when you raise by the reciprocal power, right, this is exponent to an exponent, that this always cancels each other out and you're just left with 1. So remember, when you're raising to the reciprocal power, all you have left is 1. You have x equals 16 to the 5/4 power. Okay, now I'm going to go ahead and rewrite this in radical form. Right, I know the 5 is my power and the 4 is my root. Right, that goes back to that first skill that we learned, rewriting radicals and rational exponents. So when I rewrite this, my base is 16, my power is 5, my root is 4. So now again, we're trying to determine whether we need a calculator to do this. So first thing we look at, 4th root of 16. So remember, that's telling us there's a number times itself 4 times that gives us 16. I know 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2. So that whole thing that I circled in red here, that simplifies down to 2. So if I simplify this out, that simplifies to 2, and I still have that exponent there that's just sitting there. I'm going to bring that down, 2 to the 5th power. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32, and that's my final answer. So for the one on the left side, you didn't need a calculator. Didn't need a calculator for that one. It's not appropriate to use it there. Now looking at the one to the right, I have the 3rd root of x squared equals 10. So first thing I'm going to do, I'm going to take this and write it as a rational exponent. So my base is x, my power is 2, and my root is 3. And that's going to equal 10. next thing I'm going to do, right, this is where we pick up from that first problem. We're going to multiply by the reciprocal. And you got to do it to both sides. Multiply by the reciprocal. These here will cancel out. You're left with x equals 10 to the 3/2 power. And finally, in order to determine whether we need to use a calculator or not, we can rewrite this in radical form. Right, again, this goes back to that first skill that we were using. So square root of 10. Our root is 2. Our power is 3. So first thing we look at is this here. Is there a number times itself? So a number times itself that multiplies up to 10. So you got to ask yourself that. And once you start playing around, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So there's no two numbers that multiply up to 10. For this problem here, it is appropriate to use the calculator. Okay, again, because we couldn't figure out, there's not possible for two numbers to multiply by itself to equal to 10. Okay, and then I'm going to go ahead and erase number 3. And again, if you need it, you're always welcome to rewind. And then finish up with number 4. So it says, identify a rational and irrational number. Be able to determine closure over sum and product of a rational and irrational number. So remember, the main thing we need to know is a rational number can be a whole number, a fraction, or a terminating decimal. / repeating decimal. Okay, and an irrational number, so if we're looking at irrational here, it never ends, and it has no pattern. Right, so this would be something like 3.762154992, and it just goes on forever without any pattern. Okay, going back to rational, a terminating decimal would be something like 0.125. Right, a fraction would be something like 2/3. A repeating decimal would be 0.125. Those are all rational. Okay, I'm going to go ahead and scoot up to the next section of page 1. Number 5. Okay, so it asks us to add, subtract, and multiply polynomials. Okay, so main thing here, you have to determine when to combine like terms, go straight to combining like terms, and when to do the claw. Okay, so a little feedback on it. You go straight to combining like terms when you have a plus sign in between your two parentheses. Okay, when you have that negative sign, remember that there's a -1 there, and you have to distribute that -1 to the two terms there, and then you collect your like terms. When there's no plus or minus signs between your two parentheses, you go ahead and you do your claw, right? And I'll go more into depth with this as we do the problems. And you do your claw. This one here is an extended claw. You got to do it 3 times. Okay, so remember to note that. If you see a plus or minus sign, you're not doing the full claw. Okay, so let's go ahead and start with that top left one. We have x cubed minus 4x plus x squared plus 4x minus 6. So we know that there's 2 positive ones out in front of here, so there's no point in really distributing that negative to that positive one. Sorry about that. So first thing we do is combine our like terms using our highest exponent first. Our highest exponent is x cubed, and I don't see any other x cubes, so that's going to be my leading term. x cubed. Then I go to look for my next highest exponent. It's x squared there, and it's a positive x squared, so I put plus x squared. Okay, next I have my x's left. I have negative 4x plus 4x. Right, negative 4x plus 4x, they cancel each other out. There's nothing left. I don't need to write anything. That's just 0. And the last term is that negative 6. And that there is your final answer. And remember to make sure that it's in standard form. X cubed plus x squared minus 6. Your highest exponent always has to go first. Okay, I'm going to go ahead and erase it so it doesn't interfere with the next one. And then we're going to do the one right below it. We have x squared minus 4x minus x squared minus x. So remember that there's that invisible negative 1 out in front of there that's going to change the signs inside that second parenthesis. So what I'm going to do first is I'm going to rewrite my first parenthesis of x squared minus 4x. And then that negative 1 is going to distribute to that x squared, which is going to be negative x squared. And then negative 1 times negative x, and negative times a negative. Yeah, a lot of kids forget to distribute that negative to that second term, so be careful there. So negative 1 times negative x is positive x. Okay, now I go to combining my like terms. I see x squared and negative x squared. Those two cancel each other out. And then I have negative 4x plus x. That's a negative 3x. No other terms, so that is our final answer. Alright, going up to the top right one. Okay, so again, this is the one where we have to use the claw. There's no plus or minus sign in between here. So we pull out our claw. First term is that 3x, and remember to distribute it to both of the terms in there. So 3x times x, remember x times x is going to be x squared. So this is going to be 3x squared. Then we take the 3x and multiply it to that negative 7, right? This negative stays with that 7. 3 times negative 7 is negative 21x. Then we look at our 5. We take our 5 and multiply it to the x. That's positive 5x, so that's plus 5x. And the last one, 5 times negative 7 is negative 35. Oh, I ran out of room. Let me go ahead and rewrite this a little closer. I'll write it up here. So we had 3x squared minus 21x plus 5x. And then 5 times negative 7 is negative 35. Then we look for our like terms, right? Always start with your highest exponent first. Our highest exponent is 2, right? Because we have 3x squared. There's no like term, so we just go ahead and write that first. Then we look for our x's. We have negative 21x and a 5x, right? Combine those, so negative 21 plus 5 gives me a negative 16x, and our last lonely term here, minus 35. Okay, so remember to always just double check to see if it's in standard form, right? 3x squared minus 16x minus 35, it is in standard form. Highest exponent is first. So that is your final answer, and there's no other terms to combine. All right, and the last one for this group, for number 5, we have the extended claw. Okay, so we're going to do the same thing, except we're going to do it to just one more term. So now we have x times x squared, right? Remember, when you're multiplying like bases, you add the exponents. So x times x squared gives us x to the third. X times 2x, right, that's a 1 there. That gives us 2x squared, so plus 2x squared. X times negative 6 is negative 6x. Okay, then we look at our negative 2, right? 'Cause that minus sign sticks with that 2. Let's see, we'll do this one in green. Negative 2 times x squared gives us, I'm going to keep them as separate colors, negative 2x squared negative 2 times 2x gives me negative 4x. And then negative 2 times negative 6. Negative times negative is a positive. 6 times 2 is 12. And now we go to combining our like terms, starting with our highest exponent, right? Because that's how we put it in standard form. Our highest exponent is 3. So x cubed has no other, there's no other x cubes, so that term goes first. Then we look at our x squares. We have 2x squared and a negative 2x squared, so those cancel each other out. We don't have to write anything. Next we have our x's. We have negative 6x minus 4x. So negative 6 minus 4, you're down 6, then you're down another 4, so you're down a total of 10. And then our last one, our 12 doesn't have any like terms, so plus 12. So again, check to see if it's in standard form and if you have any other like terms, and we don't. X cubed minus 10x plus 12. That is our final answer for the extended claw. Okay, number 6. I'm just gonna erase everything. Number 6 is what we just learned recently, complex numbers. So we need to simplify this. So simplify the radical into complex numbers. So remember that this square root of negative 81 can be written as square root of negative 1 times the square root of positive 81. Right? And we know from our notes that I equals the square root of negative 1. Right? That's just a little side note. So what we can do is we can pull out that I outside of the radical. So we can substitute that square root of negative 1 for I and make it times the square root of 81. Okay, now we can work on breaking down the 81. 81 can be broken down into 9 times 9. Let me do that in black so you guys can see it. 9 times 9. Okay, as soon as we have a pair, we can circle it. And remember that it comes out as 1 and gets multiplied to whatever's out there. All right, so that pair of 9s comes out as 1 9, and we're going to multiply it to that I. So we're going to have 9 times I, and then there's nothing left under the radicals, so we don't need the radical sign for this. So 9I will be our final answer there. Okay, and then same thing goes for the right-hand side. The first step is to take that negative outside of the radical. So we can rewrite this as I times the square root of 50, right? Because we know that I pulls out that negative outside of the radical. Now we can focus on breaking down 50. We know 50 is 2 times 25. And then 25 breaks down to 5 times 5. So we look for our pairs. We have a pair of 5s that comes out and gets multiplied. So 5 times I is 5I times the square root. And then we look to see what's left underneath. There's a 2 left and nothing else. So that is our final answer there. 5I times the square root of 2. And then skill number 7. I'm going to go ahead and erase all this again. Erase. Alright, so we're adding, subtracting, multiplying complex numbers. So it has a lot to do with the polynomials we did earlier. It's almost identical except for we have the i's here. So remember that these are both positive 1s and that there's no point in distributing a positive 1 into parentheses, so we can go straight we can go straight to doing to combining our like terms. So negative 3 plus 1 is negative 2. Okay, then we look at our i's. The i's are like terms. Negative 4i plus 3i. Right, negative 4 plus 3 is a negative 1i, and that is our final answer. So remember, standard form for complex numbers, for when you have I, your numbers go first, negative 2, and then your I follows. Okay, number first, and then your I follows. Okay, now going on to the middle one. So again, this time we have that minus sign in between. Okay, remember, do not do the claw here because there's the plus or minus sign in between. Never do a claw. But for this one, we are going to do the baby claw because this is negative 1 here, and it's going to change the sign inside that second parenthesis. So the first parenthesis, we're going to keep it 9 minus I, and then flip all the signs for the second parenthesis because 1 times negative 1. 1 times negative 1 gives us negative 1, and then negative 1 times I gives us minus I. And then we combine our like terms. We have 9 minus 1, that gives us 8. And then negative I minus I, right, that's negative 1i minus negative 1i, that's negative 2i. And again, remember to put it in standard form. You don't want to lose any points for not doing that. And it's 8 minus 2i, right, so we have a real and an imaginary part. Okay, and the last one on page 1. Okay, this is where we have to pull out the claw because we don't have a plus or minus sign in the middle in between here. So first thing we do, 2 times 1 is 2. 2 times 5i is positive 10i. Okay, now we focus on the negative 3i. Negative 3i times 1 is minus 3i. And negative 3i times positive 5i is a negative 15i squared. Okay, first thing we can do is combine our like terms. The I and the I are like terms. So we have 2 plus 10i minus 3i is 7i minus 15. And now here is where it gets a bit tricky because we're going to need to have a side note here. I squared is something that can be simplified. We know I squared, we know from our notes from the video that we watched, I squared equals negative 1. So we can replace this I squared with a negative 1. Okay, that negative 1 now makes this into a multiplication problem here. That's negative 15 times negative 1. So when we go to rewrite this, we can have 2 plus 7i plus 15. Right, because we have a negative times a negative here. A negative times a negative. And again, we just go to combining our like terms. We got 15 and 2, that gives us 17. So our final answer, 17 plus 7i. And we have no other terms, and it's in standard form.